Hello my dear students. So, in my last class we understood about other three important periodic properties. So, that is ionization energy, electron affinity and electronegativity. So, ionization energy is defined as the amount of energy required to remove the outermost electron from an isolated neutral gaseous atom, and opposite to this ionization energy is called as electron affinity. That is, electron affinity is the amount of energy released when an electron is added to an isolated neutral gaseous atom, and the determination of ionization energy was done by discharge tube method, and determination of electron affinity was understood by considering Born-Haber's cycle, and later on we also understood what is meant by electronegativity, that is the relative tendency of a bonded atom in a molecule to attract shared pair of electron towards itself is termed as electronegativity, and the determination of electronegativity was mainly done by using Pauling scale. So, Pauling scale of electronegativity, it is a mathematical expression. By using that we are going to determine the electronegativity. So, the electronegativity of one atom is known, then the other can be easily calculated, and the next is the Mulliken scale, where according to Mulliken, electronegativity is the average of ionization energy and electron affinity of an atom, and he proposed a relationship to calculate the electronegativity, and with the help of that, suppose if we know the ionization energy and electron affinity, so which is measured in electron volts, so definitely it is easier for us to calculate the electronegativity, right. So, this is where we stopped in our last class, and in this session, so let us understand the various applications of periodic properties. So, by studying these periodic properties, so what is the significance and what are the applications of periodic properties? The basic law governing modern periodic table states that the properties of elements are periodic functions of their atomic number. These properties, they reappear at regular intervals or follow a particular trend at regular intervals. So, this phenomenon is known as the periodicity of elements. The periodic properties of elements occur due to the recurrence of similar electronic configuration, that is having the same number of electrons in the outermost orbit. In a particular group, if we consider, the number of valence electrons remains the same. On the other hand, the number of valence electrons increases as we move from left to right across a period. The chemical property of an element depends on the number of electrons in the valence shell. So, if you keep a periodic table in front of you and observe the points what I have mentioned just now, so you can observe that the number of valence electrons remains constant in a particular group, or else if we see or if you move from left to right across a period, so then the number of valence electrons goes on increasing. So, this is a very important chemical property of an element which depends on the number of electrons in the valence shell, and this will be the main reason for the recurrence or repeated regular intervals in the properties which they are going to reappear in or at a regular intervals, and that phenomenon is known as the periodicity of elements. So, the periodic properties of an element depend on valency and number of shells in an atom. As we move down a group, the number of shell increases successively such that the number of the shell of an element is equal to the number of periods to which it belongs. As we move across a period, The number of shell remains the same. For example, so elements of the second period have 2 shells. If you observe in the periodic table, so all these points will be very much clear to you. So, in this way we can justify the periodic properties which we observe in a periodic table. Now, in this applications of periodic properties, so we are mainly concentrated on electropositive or metallic, electronegative or non-metallic character of elements. How we are going to see the trend in the periodic table. So, how the reappearance or recurrence at regular intervals, we are going to see the electropositive nature of various different elements and electronegative or non-metallic character of various different elements will be understood now. What is meant by a electropositive or metallic character? A electropositive character of an element in its gaseous state is defined as its tendency to lose one or more electrons to undergo oxidation and thus to form gaseous cation. So, this is already we have discussed while understanding the ionization energy. So, where in the ionization energy a electron is going to get removed from an isolated gaseous atom. In the same way, so here while understanding electropositive nature of a particular element in its gaseous state, so it is the tendency to lose one or more electrons to undergo oxidation. Definitely when an electron has been removed from an element or an atom, definitely it has undergone oxidation and thus it will form a gaseous cation. A gaseous cation is formed. So, here the concept of ionization energy comes again. So, the ionization energy of an element is a measure of its tendency to lose electrons and hence of its electropositive character. The elements having low values of ionization energy are highly electropositive and are metals usually, while those having high values of ionization energy are highly electronegative or they are non-metals. So, now we understood what are metals and what are non-metals. So, when the ionization energy is high or for those elements which has low values of ionization energy, they are highly electropositive and they are called as metals, whereas on the other hand if the ionization energy is high, then such elements are highly electronegative or they are non-metals. So, now we define the trend in the periodic table. So, how the electropositive and electronegative character in the periodic table is going to appear. So, with the increase in the ionization energy, non-metallic character increases and with the decrease in the ionization energy, metallic character increases. Okay. So, this is what we are going to see the reappearance of electropositive and electronegative character at regular intervals or which follow a particular trend at regular interval is in this way, in this manner, that is with the increase in ionization energy non-metallic character increases and with decrease in the ionization energy metallic character increases. So, now let us move on to the variation of metallic and non-metallic character in the periodic table. So, first is variation in a group. So, ionization energy value decreases. So, since if we see across the group, the ionization energy values is going to decrease on descending a given group. Therefore, metallic character of elements increases and non-metallic character decreases. So, this is what is observed in the variation in a group. And in variation in a period, since the ionization energy values increases on moving from left to right in a period, the metallic character of the element decreases. On proceeding from alkali metals to halogens in a given period, the non-metallic character goes on increasing. That is, alkali metals are metals and halogens are non-metals. Okay. So, this is how the variation of metallic and non-metallic character in the periodic table is observed. Next is variation of ionic or covalent radius in the periodic table. So, in that, so the first one, so let us take it as the variation in a group. The size of the atoms, that is covalent or ionic radius, increases on moving down the group because the number of principal shells increases on moving down to the group and the distance between the nucleus and outermost electron shell increases. So, usually the principal shells are KLMN shells and it is represented as 1, 2, 3, 4 respectively. So, if we move down the group, the principal shell increases. So, on moving down the group, when the principal shells increases, so the distance between the nucleus and outermost electron shell also increases. So, cesium is the largest element in the periodic table. For example, in the first group, if you observe in the first group of the periodic table, so size of the lithium is greater than beryllium, okay, and this beryllium size is greater than boron and its size is greater than calcium and it goes on. So, other example if we take in the first group of periodic table itself, the size of lithium is lesser than sodium, sodium is lesser than potassium and the size of potassium is lesser than rubidium and the size of rubidium is lesser than cesium. On moving from top to bottom in a group, number of shells and effective nuclear charge both increases. The increase in number of shells tends to increase the covalent radius, while increase in the effective nuclear charge tends to decrease the covalent radius. But the effect caused by increase in effective nuclear charge is lesser than the effect caused by the increasing in the number of principal shells. So, covalent radii goes on increasing. For example, in the second period, the size of lithium is greater than beryllium, is greater than boron, is greater than carbon and so on. Okay. So, next is variation in a period. On moving along a period, both covalent and ionic radius decrease because the electrons are added to the orbitals of the same shell. That is, the principal shells remains the same here. So, this is very important, variation in a period. So, here we have to observe that the principal shell remains the same. So, that is why the covalent and ionic radius is going to decrease. So, as the principal shell remains the same, but the effective nuclear charge increases as we move from left to right in a periodic table. So, this is the trend which is observed in the periodic table considering the variation of ionic or covalent radius. So, next is oxidizing and reducing properties. So, how the oxidizing and reducing properties reappear at regular intervals in a periodic table. The elements which have strong tendency to accept electrons to undergo reduction in aqueous solutions are called as oxidizing agents, and those which have strong tendency to lose electrons to undergo oxidation in aqueous solution are called reducing agents. So, the trend observed in the periodic table is as follows. On moving along a period, electron affinity value increases. So, the addition of electron is easier. So, the elements undergo reduction or they act as good oxidizing agents. In the periodic table, group 17 elements, that too especially the halogens, are good oxidizing agents. Whereas, on moving down the group, ionization energy value decreases. The elements can lose their outermost electrons very easily, so they act as good reducing agents. For example, lithium is the strongest reducing agent in aqueous solution. This is because it can lose its outermost electron easily and forms unipositive cation. A very important note has to be made here. Even though the reducing power of alkali metals goes on increasing down the group, lithium is the strongest reducing agent, because reducing power depends on hydration energy. Hydration energy of lithium is maximum, so it is the strongest reducing agent. Next is about effective nuclear charge. So, what is meant by effective nuclear charge and what are Slater's rule for calculating effective nuclear charge? So, we will see in my next class. Thank you, dear students.